Today we are building a lithium-ion battery, 14.4 volts nominal voltage, 18 amp hours, out of recycled lithium-ion cells. Everything can be obtained from battery hookup, and I leave links in the description for you. Also a discount code for 5% off. Let's get to it. I just got a shipment in from battery hookup. If you place an order with them, use my discount code SIMPLICITY. Let's see what we have in there. Yeah, first thing is a DC power supply. They're supposed to be pretty good. It's adjustable up to 30 volts, and I think this one is a 10 amp power supply. Looks pretty good, has a fan in it. These are the battery cells I bought. They are 18 amp hours, lithium ion. Here we go. It looks pretty good. So I bought 8 of them. And then I have 2 battery management systems. You need those, and these are for 4S lithium ion, so 14.8 volt nominal. So they are specifically made for cells with a maximum voltage of 4.2 volts. Charge current 20 amps and discharge current 30 amps. So that's perfect for me. Now let's peel the tape off. Yeah, so they seem to be stacking pretty easily. They have hardware on it. These are all the positive terminals on this side. And of course on the opposite side you're going to have your negative. So they come apart like so. Here it is, single cell. We're going to use 4 of these in series to generate, what is that, 14.8 volts nominal. So we're just going to stack them and then put this BMS on it. The first thing I got to do is, these cells, they are tested and they are supposed to be the same voltage, but the first thing you want to do is you want to top balance these. So I'm going to hook them up to this adjustable power supply, set the voltage at 4.2 volts and just let them charge for like a day and a half to make sure all the cells are at the same state of charge. So here are the BMSs. Yeah, nice and compact. Yeah, 4S, 30 amp lithium ion. This board also has active balancing, but it's somewhat slow because it's only in the milliamp range. Yeah, you want to make sure these cells are all top balanced to 4.2 volts each cell to make sure you have full capacity. So let's check the voltage of each cell, see how close we are. 3.85, 3.86. Second cell, 3.5. It's quite a difference already. Third cell, 3.80. And the last one, 3.85. Not too bad. Let's check the other ones. The one is just a little low, which is not a problem. 3.85. 3.85. 3.85. These are much better. 3.89. Almost 3.9. Okay, so overall not too bad. You know, these are used cells and you just gotta top balance these. And I just hooked up my power supply here. It's actually a pretty cool power supply. So what I'm going to do is I'm going to choose a voltage. You got 2 voltage adjustment knobs here. One is coarse and the other one is fine. So I want to charge these to 4.2 volts each. There you go. Oh, wow, look at that. Lucky. And then you can adjust the current here, whatever current you want. So It goes up to 10 amps, although these wires are a little thin for 10 amps, I think. So these are 18 amp hour cells. So 1C would be 18 amps. So I can easily charge these with 18 amps. Power supply can only supply 10. I think I'm just going to charge them with like 8 amps because these wires are pretty thin. So I got to build some bus bars, connect all the negatives together, all the positives, and then just put them on the charge and charge them all the way up to 4.2. And then check the voltage one more time after they sit for a night or so, and I don't think there are any bad cells in there. So let's do that. So before I charge any live batteries with this, I want to make sure that this voltage readout is indeed accurate, because you cannot charge these lithium ion cells above 4.2 volts. So 4.18 is already giving me 4.2 on my multimeter, and I trust this multimeter a little bit more. So I'm just going to adjust this down. If I'm slightly below 4.2, it's okay. Here we go. 4.198. So the readout here is about 4.17. So I think that's important to know before you first hook up any live cells. So the second cell is a little low. This is the only one. They are all at about 385, except for the second cell, which is at 3.5. See, these are 3.8, 3.85. So the second cell is too low for my liking. So I'm going to bring the 3.5 volt cell up to 3.8 or 3.85. All other cells, like the second pack, is really good. It's really consistent, 3.8, 3.85. So these are all good, 3.82, 3.82. So I got to bring this second cell up to 3.85. This power supply has a coarse and a fine voltage adjustment, which you would think it's nice, but they are both pretty touchy, okay? Here 3.8, that's fine. 3.84, 3.81. So again, this display seems to be reading a little low. So for bus bars, I have some 6061 aluminum flat bar laying around. Here we go, this one. And it's an 1/8 of an inch by whatever this is. What is this, an inch, 3/4, something like that. So what I'm thinking is I need 2 bus bars to top balance these cells. So I'm just going to cut two lengths off and then drill the holes and then connect all the positives and all the negatives and then get this thing charged. So let's cut this off real quick. Okay, I'm not going to be too proud of this, and I'm not taking too much time. I'm just gonna eyeball this here real quick. Drill my holes. Just gonna draw a center line, make sure they're at least on center. Yeah, these are the 2 bus bars. I'm not too proud of them, but I think they're gonna work just fine. This battery is at the same potential, so all these cells are pretty much the same voltage, so I can attach these to these bars here. And this is pretty good for eyeballing it. So some of these hex nuts are 7mm head and some of them are 8. So they're definitely different hardwares or different, cells. So let's see here, this is an 8mm, so I get this guy tightened. You want to make sure Yeah, here we go. Something is beeping. Okay, here we go. So this is one side, so all the positives are now connected. And I'm going to do the same with all the negatives. You know, just pick one. It probably doesn't matter which one. Maybe I should do the opposite side for this guy. And then I have everything in parallel. And then I can charge the entire pack to 4.2 volts. And let these guys balance out. Make sure every cell has the same potential and is at the same capacity. 7 millimeters. Let's tighten these up. There you go, nice. Okay, very good. So this is what this pack looks like now. So all the negatives are connected with this bus bar right here. All the positives are connected with the bus bar right here, nice and tight. So you would think that this cell now would auto balance, but in case of lithium, it really doesn't. Because the voltages are so similar that they could be at a different state of charge, and that's why you need to top balance these. Okay, I think we're there. Let me measure the voltage of that cell. It's at 3.89 versus the other cells at 3.85. So it has slightly higher potential right now, 3.85. But it just got off the charger, so hang on. Yeah, 3.89, so that's good. So I feel comfortable connecting the bus bars to the positive terminals and the negative terminals, since the potential is pretty much the same. And this is good. So the cell came right back up. I'm not going to charge this right now. I'm going to charge this guy, which I've already installed bus bars to. So all the positives are connected, all the negatives are connected. So the battery, you would think, should be at the same potential, that all four cells are at the same potential. So I gotta charge this guy up. Let me see what the voltage is on this battery here real quick, since they've been all connected for a while. Yeah, 3.86 volts, so that's good. So I got a top balance these at, you know, I would like to think I'm gonna get these up to 4.2 volts, but I may need to run them at a little higher voltage to get some amps into them. Here we go, I think this is good. Here 4.2, here positive is positive. Here we go. And over here, negative bus bar. Okay, nicely in the middle here. Usually bus bars, they don't care too much. Here we go. So currently this battery is charging at 4.4 amps and it's restricted by the voltage of 4.2, which is perfect. So any cell in here that has slightly lower internal resistance will take a little more charge, right? It will take the, more electrons than others. So the theory here is that by the time we are done charging this all the way up to 4.2 volts, every single cell is exactly at the same state of charge and has the same voltage. So I'm gonna keep an eye on this. The amperage should taper off. It'll probably take a few hours before it does, and we'll see. So this is 18 amp hours, 1836, so 72 amp hours. Right now this is a 72 amp hour battery, 4.2 72 amps. I can't get more amperage into it because I'm restricted by the voltage it's currently recording. So give it a few hours, the amperage will drop, and then we'll see how it goes. Well, it's 600 milliamps, okay, 600 milliamps, but it'll balance these cells. And again, I'm gonna leave this on for a few hours, so all these cells will be balanced nicely. But you can't go over 4.2 volts. So let these guys sit, let these guys charge, let these guys get up to 4.2. Everything is gonna be nicely balanced, okay? Whatever has the lowest internal resistance is gonna take most of the charge, and to be honest, let them sit overnight, and we'll check them tomorrow morning, and they'll be below 4.2, but I bet you they'll be pretty darn close to each other, and that's mission accomplished. And then we can assemble these batteries. We can put the BMS on it, which is a really nice BMS here from Battery Hookup, and we're gonna have a couple of pretty nice batteries. So these are the cells we top balanced yesterday. So let's see what the voltage is on these. Uh, 4.18. So perfect. So since we top balanced these cells and they set overnight and they're still at 4.17 volts, we can start to assemble them into a battery, into a 4S configuration. So I'm going to take these bus bars off, cut them in half, and then connect these 4 batteries in series. So after you top balance your cells and you disconnect them from the bus bars, it's a good idea to let them sit for a couple of days and just to see what the voltage looks like. And let's see what we have here. 4.17, 4.17, 4.17, 4.17. They're exactly the same voltage, which is great. So the next thing you want to do is, these are all the positive terminals, and on the back are all the negative terminals. You want to configure this battery in a 4S configuration. And the way I do it, I just turn these cells around, positive to negative, positive, and then turn this guy around to negative. Well, this is how the cell should be configured. So this is going to be your main positive, and then you connect this negative to this positive. It goes to this negative to this positive gets a bus bar. It goes through here, and then this negative to this positive gets a bus bar. So this will become your main negative. So you're going to have your main positive, your main negative, and that would quadruple your voltage. So I'm at 4.2 volts roughly right now, times 4 would be 16.8 volts. So with these cells, I'm just using zip ties to secure the cells. You can use hardware, but I don't think it's necessary. That's all that's required here. Here we go, all secured. Now I gotta take my bus bars off, cut them in half, and that's what I use for this battery build. So since this is my main positive, actually I'm gonna go to the back of the battery. So this negative goes into this positive terminal. You want to tighten these fairly tight. Okay, now these two cells are connected. Be careful not to shorten out this battery. So positive into negative into positive. Okay, negative and positive. So now I got to connect these two guys. Nice and tight. So this positive goes to this negative back here. And now this negative needs to be connected to this positive. Okay. So one more check here. Main positive goes over, connects to this negative, goes through the battery. This negative connects to this positive, goes through the battery, and then this negative to this positive. So this becomes my main negative. So nothing sparked. And if we did everything right, we should have 16.8 volts on this thing. Let's see. Main positive, main negative. 16.7 volts. That's your battery. So now everything is connected. Now, of course, you cannot build any lithium batteries without a battery management system. So that's the next thing we got to think about, how to place it and how to wire it up. So this is the BMS that I bought for this battery. And you want to be near the main negative terminal. So you have a B minus on here and you have a C minus on here. B minus is battery negative. So I got to connect this terminal to the main negative of my battery. And then the negative goes through the BMS. The BMS then senses all the cell voltages that we have to hook up to each individual cell and passes it through to the main negative. So my main negative for the battery will come out right here on this terminal. It's going to go forward. And this is my main positive, so my main battery leads are going to be here in the front. Trim off the excess. Looks good. Let's mount this guy up. So battery negative, this is the main battery. Negative, so this needs to go into this terminal here. So for these thicker main wires, you need yellow connectors, of course, not blue ones. These are going to be used for the BMS. So negative to the battery is crimped and soldered. So let's see how we can place this BMS on this battery. I use double-sided tape, and I'll leave a link for you in the description. This is this foam double-sided tape. It's really good. And I'm just gonna tape it on the top of the battery. And this main terminal needs to be connected to the battery. You can bend this up a little bit, like so. And just loosely hook it up for now. And then see where the BMS sits. Yeah, something like this. Yeah, make sure it all looks good. I'm gonna put a new zip tie around this conductor here as well, so everything is secure. I think that's a pretty good solution. Yeah, so this is where the BMS would sit. The main heat dissipation goes up on the BMS, so this is an aluminum plate, and at the bottom is just a rubberized surface, so it's not a problem to use double-sided tape and mount it just like this. Yeah, double-sided tape on it. Make sure the surfaces are nice and clean, and then mount the BMS the way it has to be mounted. Okay. So this is main negative. I'm gonna put an Anderson connector on it just to insulate it, because I don't want to shorten it out against this battery. Even though the BMS is not turned on yet, it's good practice to insulate this. So these are 30 amp Andersons. Make sure the lip points up. Okay, it's crimped on. Then you can put the insulator on it. Okay, that's it. It's your negative. We can do the main positive next. Let's get a piece of conductor. Put a ring terminal on it, just like we did on the other side. Okay. In this case, we use yellow. Cut the insulator off so it looks better. There you go. And let's crimp it on and also solder it. Use a decent crimping tool for these. Okay, crimped. Let me solder this up real quick. Here we got a good solder connection on it. Bent this ring terminal up. And then it's gonna go onto the main positive of the battery and face forward. And it'll also get an Anderson. So let me see what the length has to be. I'm going to place another zip tie here just to hold these conductors securely. And let me cut the other one off. It's the new one. And in this case, it's not a bad idea to double them up. Okay, that's one of them. Let's do another one. This also acts as a strain relief for your conductors here. So this goes forward. It's going to be the same length as the main negative. So I got to cut it off probably right here and then put my Anderson on it. So your main positive. Put your Anderson on it. Sometimes you have a couple of stray wires coming off here. It's okay. This wire is oversized. Let's cut those off. Okay, you got to make sure for this Anderson that also the lip points up and it goes on the right. Just crimp this on here. Okay, all crimped on. Put your insulator on it. This metal piece goes up. There we go. And then you can slide your two Andersons together. There we go. That's your connection. You can put a roll pin in the middle of it, which is probably a good idea because these conductors are pretty thick. So let me get a roll pin for it. Here, this is what this looks like. Tiny steel roll pins. And you just insert one in between these two Andersons. It keeps it from sliding apart. There we go. There we go. Looks pretty good. So the only thing left to do is to connect the balance leads to each cell, and then our battery is finished. Whenever you buy Andersons, make sure you buy the real Andersons from a good supplier. There are a lot of Chinese knockoffs on the market for cheap. Don't cheap out on these Anderson connectors. I had some bad experience with the knockoffs. So let's look at the wiring diagram for the battery management system. So this is a battery management system. We have our main negative connected to the BMS, which is this wire right here, okay? And then the battery negative main terminal comes out the other side of the BMS, which is indicated by these wires right here. Sometimes there's more than one terminal depending on the amperage rating. The positive just goes from your battery to a positive. It doesn't go to the BMS at all. Now here are these balance leads, and you have a main negative that goes to your main negative terminal, and then each battery gets a conductor so that the BMS can measure the voltage of each cell. So first, second, third, and then main positive of the battery. Let's see. So the BMS, in our case, it's a lithium-ion chemistry. It's a 4S. Here just the voltage is fully charged, 16.8. Nominal is 14.4 volts, and then the cutoff voltage is 11.2. So this is what this BMS will manage. These balance leads are thin, okay? I start usually with my main negative. So on the far right is your main negative, and then you have first cell, second, third, and then main positive. So let's see how this plugs in, and then we can run our wires. Here we go. So this clicks right in. So the main negative, I'm just going to solder it here to the BMS because it's a nice short run. It's going to look nice and clean. So that's good. I can cut that conductor off right there. Because this goes to the main negative. Now all the other conductors have to be equal length. Otherwise you're going to have different voltage drops within these wires and your battery is not going to have full capacity. So what I do is I dry run all these wires to the terminals they need to go, and then I determine the shortest length I can cut them to without, sacrificing the length of each individual conductor. And I'm gonna cut them all the same length. And then I have a little bit extra in some cases, but I can still reach my furthest terminal. Okay, another thing we need to do here, these screws are a little too long if you don't use bus bars on it. Like my main negative and my main positive, I'm just gonna attach it right to the battery. I'm not putting any bus bars under it. So the screws are therefore a little too long, and these are M5 screws. You can just mount shorter ones if you like. Some of you probably just use washers. I'm not going to do that. I'm gonna cut these off. So I put an M5 nut on it. I'm gonna put it in my vise, and then I'm just using one of these cutoff wheels, pneumatic cutoff wheels. It's like super thin. And I'm just going to cut off, 1/4 inch so that they are nice and flush, that they don't, penetrate into the cell itself. So let me get that done. Here we go. Just takes a second. And now we can use these to mount my ring terminals. This is my main positive. Nice and tight. Okay, my main negative is already soldered to the main negative. Now the next wire over is the first white wire, and it goes to the positive terminal of the very first cell. So this is my main negative. So I want to put it on the positive side of the same cell. So it needs to go right here. Okay. The second white one goes to the positive of the second cell. So it's the first cell negative, first cell positive. So it needs to go right here. Okay, and the third white one needs to go to the positive of the third cell. First, second, third. So it needs to go either here or here, one of them. Whatever one you can reach. It's a little too tight for my taste, so I'm just gonna exchange this screw with a shorter one and mount it right up here. Don't show me all these cells now. This one. Okay, that's good. The last thing to do is I use a hot glue gun and run these wires here a little bit nicer. I may reroute this to go underneath. Yeah, let me reroute this out. So the BMS is now connected, and if I did everything right, I should have 16.7 some volts over here. Let me just see. Yeah, 16.67 volts. Okay, last thing to do is we're going to use a hot glue gun and route these wires here, and so make sure it looks halfway decent. Yeah, this is a powerful, lightweight, inexpensive lithium battery. So that's all I have for you today, and I'll see you guys on the next one.